Every day you have 10 o'clock? 10, okay, before I'll take. Okay, good morning, beta. Better we can connect speakers also, na? Speakers also can connect. There. No, better this is. Where you can't connect, no? Interaction can be there, na? And we are regular now, we can maintain setup. Nobody is there, na? There's later problems, syllabus won't be completed. Students, can you hear me, beta? Please respond. Vaishnavi? Vaishnavi? Can you hear me? Vaishnavi, can you hear me? Can you hear me, Vaishnavi? Can you hear me, beta? I cannot hear you. Please respond. Voice is coming, but your voice is not audible. Okay, good. So just I'll wait for 2 minutes. Good, good. So you can see the screen. But as I told you, today we start vector algebra, and it is easy, and we can complete by 1 week. And already I have sent you a video yesterday. Yes, to go with the standard core concepts, which will be covered by me also. And same time, we'll cover exemplar and NCERT like earlier topics. Okay, but run Vijay, clear? And after vector algebra, we'll go to linear programming. By this vacation, we try to complete these two, which are easy topics, and then we'll move to the standard topics, which are lengthy. Okay. So others are expected to be joined fast because I already informed yesterday. I am finding Sanya, Vaishnavi, and Ranvijay. Only 3. Others are ready to join fast. 2 or 3 minutes, I'll wait. Okay. Right, but I'll start. I will not waste much time. Okay, vectors. So the term dealing with vectors is nothing but vector algebra. Yes, but can you hear me? Please respond by yes. I think you are able to see and hear. Clear? Okay. Right, but yes. So good. Right. Now, vectors means, but already you have learned in physics also this concept or term. See, vector is okay a quantity which has magnitude and direction, both, which has magnitude and its value and its direction also there. That is called vector. But already you heard what is a vector in physics also. See, velocity and speed. Velocity and speed. You know the difference of these two? Both are rate of change of time only, distance only, but this is vector, the direction is there, and this is scalar. Scalar means just other way. What is a scalar? A quantity which has only magnitude, which has only magnitude. But what is missing here? What is missing in vector scalar? Direction. Direction is not there. But in the case of vector, direction also there. So direction is indicated by arrow. Like this, like this, like this, like this, like generally. Right or not? Direction indicated by arrow. Already you know it in the traffic signals or in any way, arrow or direction maps. Direction indicated by arrow. So what is general way of representing a vector? A bar, B bar, C bar. Yes, madam? Clear? Bar means, or else I can write vector in this way. AB vector, BC vector, CD vector. Both are same only. What is the difference of both of them? Like length of a side, I will write BC. BC is equal to small a or not? Same way, I can represent with a single letter or represent with the end points. This is called indicating a vector with the end points. So this is called initial point. This is called the terminal point. Yes, madam? So from A to B, the vector is like this. See, always there should be B, but A to B, then arrow will be there. Don't be combine both of them. Generally, you won't mark it here. This is meaningless. You have to show B also. A, B, then vector. So A to B, indirectly. Understand? This is directionally. A, B is a value. Magnitude is A, B. And direction is from A to B. Are you clear, madam? So don't confuse with the, you have to keep end point. And then you can write arrow also like this. No problem, anywhere. Are you clear? This is called A, B vector. Direction is only flow. Flow from A to B. Traveling from A to B. Or you can write B to A also. But there is end point for B and A. Because this has magnitude also. Vector means magnitude also there now. It's a length. Okay. So AB vector is this way and BA vector is this way. But our direction change from B to A is coming. So I can write BA vector as like this also. Yes or not? So I can write AB only I can show. But if I show AB like this is equal to BA vector only now. Are you clear? Both of them same only now, beta? Are you clear? A vector in this way, if you write, is equal to B vector only. Understood or not? So because arrow starting is arrow direction is beginning, this is called initial, this is terminal. So here initial is B, here also initial is B, terminal is A, terminal A. That means both are same only. Yes, beta? So now A vector I can write in this way is equal to, it is initial point is A, terminal point is B. So here if I write BA, it is changing. So direction is changing. So minus. So direction changing means direction change, initial and terminal points are interchanged, the value of the vector will become minus sign. Yes, but clear? The interchanging of the terminal point and initial point is going on, then the value of the vector becomes negative. Again, if we change both sides, minus of minus AB vector. The same only, AB only. So if I interchange the initial terminal points, one minus will come. Are you clear, beta? Yes, because it's a matter of direction, so you need to be careful with the end points and terminal points, initial point and terminal point. Are you clear till now? What is vector? So you know speed is a scalar, there is no direction for it, only it has value. 5 meters per second, 10 meters per second, 20 meters, kilometers per hour, like that. And in case of vector, the direction also will be there towards northeast, southwest, traveling direction, likewise. So if you go with the direction as well as magnitude, it is called the vector quantity, and it is going only with the magnitude. Magnitude means its value, pariman. Okay, its size. Size means the length. Okay, or the what you can say measure. That is called magnitude. So it is only is called a scalar quantity. So if I take any constant, it is a scalar quantity. Beta 5, number 5, minus 3, 15, 22. These are scalars. Yes, beta. So all the numbers are real numbers, and the numbers are scalar quantities. But what about vector quantity? I'll tell you vector, how it is represented, what is the standard form, that all we'll discuss now. Can I write this part? Students, understood now? Student, understood until now? What I discussed? Scalar, what is meant by vector, how it is represented, that all we discussed until now. Yes? This is very easy and interesting also, simple also. Can you hear me, students? Can you hear me, students? Okay. Note it down. Just will continue next. Okay, but can I erase the board? Can I erase the board? Okay, okay. Just wait. Okay, right. Okay, we'll continue that now. Now we'll see what is a vector, what is stand for. But I have this one, three-dimensional space. It's I bar, J bar, and K bar. Three-dimensional space, you know, one is x-axis, one is this x-axis, y-axis, z-axis, y-axis. Okay, so I bar, J bar, K bar. If I bar, these are all called, but this is cap. These are called unit vectors. Unit vectors along three coordinates axis, x, y, and z. I bar, J bar, K bar are called unit vectors. But what is unit vector? They are indicated like this. Unit vector. Magnitude 1. So mod I cap is equal to 1. Mod j cap is equal to 1. Mod k cap. But unit vectors are indicated by cap. They are called I cap. Only this will be indicated by cap. Remaining are like this only. Bar only will write. This is called cap. I cap 1, J bar cap 1, J cap 1, K cap 1. Okay. So what is the standard form of vector? Standard form of a vector. So what is unit vector? Whose magnitude is 1. Okay. Railways. 3 direction will have 3 vectors, unit vectors, and they are called I cap, J cap, and K cap. Good. Yes. Yes, yes, madam. Run with B to A. See, A to B is one side, B to A will be negative, interchanged. Suppose B to A is there, A to B means it will be interchanged. Interchanging means negative will come. Standard form of vector, this is called beta component form. This is called component form. Okay, I take here suppose A bar, xi bar plus y j cap, like the new vectors with the light. The z k cap is xi bar plus y j bar plus z k bar. You can get it as like this. Similarly, I can take as A vector A or vector P is equal to P1 I bar plus P2 k j cap plus P3 k cap. So resolved vector, this is called. Suppose Q cap, I take here Q vector. Okay, Q1 I cap plus Q2 j cap plus Q3 k cap. So every vector is written in the form of a component vector. 3 forms component, resolved component vector. Are you clear, beta? Component vector form understood all of you? Yes? Clear? Please note it down. These are introduction only. We are learning what is basics of vector algebra. We'll continue further. Have you noted, beta? Component form understood? Can I raise the board? Okay. Can I raise the beta? Yes. Now see here. Next one is, you have to understand the magnitude. Zero vector or null vector. Both are same only. Null vector. Vector is magnitude 0 and direction no direction. Because it's a no direction, because it's a point vector. It's a point vector. But if I keep a point, what is the vector? No initial, no terminal point. So initial point and terminal point will merge. Initial point and terminal point will merge. Both will be merged. Initial point, terminal point, both will be merged. That is called the zero vector, null vector. So magnitude, suppose A vector, but initial and terminal. A is initial, A is terminal. So no magnitude, zero vector only. It is called zero vector. Because the direction, na? Zero you can't write, but zero is a scalar. Yes, but zero is a vector means zero vector. This is zero vector. Understood, na? So you can't write this as zero. Because you are saying it is a vector formula. So A vector is equal to zero vector. B vector. Zero vector. XX vector. Zero vector. Understood, madam? Yes? Because vector is always you keep a bar or sign like this. Arrow. This is scalar. Zero is a scalar. Zero vector is a vector. You have to write. Understood, madam, friends? Because we are talking about vector here. Vector cannot be equal to scalar. Yes, vector cannot be equal to a scalar. So vector should be indicated only with vector form. This is called null vector or zero vector, and this is called a point vector also. No magnitude and no direction. Clearly, initial and terminal point will be coinciding. That is called the zero vector. Are you clear, beta? Yes, got it. Not all. Clear, but all of you? Again, go to the video. I will send each one. Exercise wise also I will send, so you will easily understand. Can I raise the board, beta? Can I raise, beta? Yes, what is that after initial and terminal point? But both will be merged, coincide, merged. Okay? Merged means combined together. This is called merging. Okay, merged. Both will be merged. Clear but understood? Merging means mixing together. Both are overlapping. That is called merging. This is only A, this is only A. Both are A only. That is called merging. Okay, but clear? Yes. Now see here. Now see beta, AB vector is equal to minus of BA vector. Yes or not? Because I interchange the initial terminal points. Are clear? That is equal to that also same only BA vector minus of. Okay? Both are same only beta. These two are equal. See, arrow is B to A, here also B to A. Are clear? Understood beta, clear all of you? Understood? You have to see both ways. Direction as well as alphabet. Yes, beta, clear? Clear but understood all of you? I can say same way. XY vector minus of YS vector or minus of both are same only. See it. YX vector, XY vector. These two are equal and these two are equal. Clear? XY, YX. So minus. Understood? Now? Here minus YX. Here arrow is same. That's why you kept these two are equal. And here is arrow interchange. That's why these two are given. Are you clear, beta? Yes, understood all of you? Clear? Yes. Okay, now see here. Vector addition. We'll see but how it is vector addition. One is triangular, one is parallelogram law. This is the resultant vector. Always better it will be with the two vectors only. Both cases are, if two vectors are added, how to get the resultant vector? It is by vector addition is possible by two ways. Triangle law and other one by parallelogram law. Both are different, but both cases we deal with the two vectors only every time. If two vectors are added, how to get the component resultant vector by triangle law, and two vectors are added, how to get the resultant vector by parallelogram law. Both you have to take. Yes, but clear? Now see here, triangle law, how it comes, you see. But you take any triangle. Take any triangle. Yes, is a triangle or not? Yes, but any two sides you take. In a triangle, take any two sides in the same direction. In the same direction. But any two sides you take. AC, BC, AB, BC, but continuous. Continuous sides. This is important. So I take AC, CB, AB, BC, BC, CA, BA, AC, CA, AB, CB, BA. See, but all possible. AB, BC, AC, CB, continuation. So AC vector and CB vector you take continuation. Suppose first case. Same direction both the continuation or not? Are they going in the anti-clockwise direction or not? Clockwise direction they are. Then resultant vector. I am writing here. Resultant vector will be in the opposite direction, joining initial and terminal points. But a join initial and terminal point. Resultant vector will be in the opposite direction, joining initial and terminal point. See, AC plus BC I am taking. You leave this part first. AC vector plus CB vector. What is initial point? A. Both are same direction. Then what is resultant vector? Opposite direction. So what comes? See, these two are in this way and this is going in this opposite. So joining the terminal points, AB vector. That is clear, brother? That is now AC vector plus CB vector is equal to A vector. So these two are coming in this direction and this is going in this direction. Are you clear or not? This is clockwise. So in this direction, they should come like this arrow. But we took the opposite direction and end points only took. This is called the vector addition. Are you clear? But you take another one, AC plus BC, AB plus BC. Just remove the common, then add the end points, AC vector. AB plus BC, this direction. So reverse will be in this direction and AC vector will come. Yes, but clear? Similarly, BC plus CA. Remove the common point. So what comes? BA vector. End points you take. First point and last point. And direction opposite. See the opposite. Similarly, BA plus AC. Remove the common and take the initial terminal point, BC. CA plus AB. This is to better CB vector. Remove the common and first and last. And CB plus BA. Remove the B common and take the CA vector. Yes, but clear, got it? Students understood, beta? How the vector addition takes place between two with respect to triangle law. Only two vectors sum we are taking at a time and then we are using the output triangle law addition. Students clear, but all of you understood? Can I rest, beta? Yes? Good. Now, we'll go with the parallelogram. Triangle. See, parallelogram. But now, you are taking if any two vectors are with the same initial point, means co-initial vectors. They are called co-initial vectors. But two vectors are with the same initial point. So I take here A, B. So AB vector and AC vectors are called co-initial vectors. Okay, because both are having same initial point. One more thing is there, beta. Now this is having co-terminal vectors, BO vector and CO vector. See, they are having same terminal points, same terminal points. So they are called co-terminal vectors. This is called co-initial vectors. This is called the co-terminal vectors. Are you clear, beta? So n points are same. They are called co-terminal vectors. Initial points are same. They are called co-initial vectors. Yes, beta, clear? Got it? Understood, beta? Co-initial vectors and co-terminal vectors. Clear, all of you? End points are same. They are called terminal co-terminal vectors. Initial points are same. Co-initial vectors. Yes. Now, I'm talking about if two vectors are with the same initial point. They are called co-initial vectors like this. Yes, are the initial co-initial vectors or not? OA vector and OB vector. Yes, beta. Then OA vector plus OB vector I want to take because these two are like or as adjacent sides of a parallelogram. But are the adjacent sides of parallelogram or not? They look to be because initial vectors only. Then the resultant vector will be the diagonal between the two vectors with the same initial point. So what comes, beta? There is a diagonal. This is something you see, OC. So that you take as OC vector. Beta, the resultant vector is equal to Y vector plus O vector. They are adjacent sides of a parallelogram with the same initial point, co-initial vector. Then the resultant vector output or the sum of them is equal to diagonal of those as sides. So you take here this diagonal is called the OC. The diagonal vector is nothing but the resultant vector. Understood, beta? So this is in second case, parallelogram vector. What is the condition for parallelogram? Two vectors have same initial vectors. But for the triangle, two vectors have first vector terminal is equal to second vector initial. That is the condition for terminal. For triangle, AB vector plus BC vector will take. First vector's terminal point is equal to second vector's initial point. In this case, only two vectors again, same initial co-initial points. That is called the resultant will be equal to the diagonal of the two sides having its parallelogram as the output. This is nothing but OA plus OB is equal to OC vector. And the diagonal also has the same initial point. And it is nothing but the end or the diagonal of a parallelogram with these two initial vectors as sides, adjacent sides. Clear but understood? Understood, beta? What is parallelogram law of vector addition, triangle of vector addition? Yes? I will notate because these are the principles. Once we know all these things, we'll go to exercise next. Very easy only. Yes, but clear? Can I erase? Okay, right. If two vectors are added again, you'll get a vector only, but subtracted vector only will come. Output is again vector. So you can say here, I can write here A bar plus B bar is equal to, can I write B bar plus A bar? Are they same? Okay, so this is called vector addition is commutative. Commutative. Okay, order change, they have the same value, right? P bar plus Q bar is equal to Q bar plus P bar. This is called the commutative. Okay, but otherwise AB vector plus BC vector is equal to BC vector plus AB vector. No difference. Order change also, value will not be changed. Let's better 2 plus 3 is equal to 3 plus 4, like that. 3 plus 2. No change, na? So this is called commutative property, order interchange. So for every A plus B, for all A comma B belongs to R, A plus B or A star B. This is, we do not have a syllabus, B star A. Then this is called commutative. Chapter 1 we have to get this, but this is out of syllabus, so we will not take binary operation. Okay, same path, instead of star we took plus here. Commutative is A star B is equal to B star A, then it is called the commutative. Yes, beta? Clear? Now I take here, for every A, B, C belongs to R. A star, B star C is equal to A star B star C. This is called a star is associative operation. Associative means 3 will come better. This is called associative. Similar vector addition is also associative. See here, A bar plus B bar plus C bar is equal to A bar plus B bar plus C bar. Vector addition is associative. Vector addition is associative. You are taking gold on. Yes, but clear? Vector addition is commutative and vector addition is also associative. Clear, but yes, right. Can I erase? Yes. Now we are going with the vector multiplication and then vector super product. These two are left, that tomorrow and after will continue. Okay, beta? So today you go through that video and I will send some more videos. Okay, and go through try to read the textbook, read NCERT and examples before 10.1. This is for today's work. Okay, beta? Read NCERT, vector algebra topic. Okay, this is part 2 beta topic, chapter 10. This is we are covering into part 2 part, but no problem. The NCERT part you read and then do examples before 10.1. Okay, I will send 10.1 exercise video solution so that you can go for completion of the 10.1 also and complete 10.1. I will send the video also. Okay, beta, clear? Yes, beta. Tomorrow will continue same time. Inform friends, they are missing. Thank you, beta, all of you. Yes, we are doing only 1 hour and I will give 1 or 2 hours work only. So enjoy other holiday, other time. Okay. Thank you all, beta. Inform others to join without missing.